In connection-oriented demultiplexing, there is an end-to-end connection in place like a pipe. This logical connection is between the destination and source processes, and therefore, information about both of the source and destination processes are needed to ensure segments belong to the same connection. Therefore, in connection-oriented demultiplexing, as in TCP, the socket is identified by a 4-tuple: source IP address, source port number, destination IP address, and destination port number make that 4-tuple. A host, especially a server, for example a web server, might have many simultaneous TCP sockets. Identifying the sockets for those different connections, which might be for the same application, needs source information as well. Assume we have 3 hosts, A, B, and C. Host B is running a server application like a web server. The server on host with address B has a known port for the server, which is port 80, tied with different sockets to different parallel processes running the same application. If host A and host C decide to initiate connections to the HTTP server on server B, they need to address their segments to port 80 on host B. Each TCP socket is identified by a 4-tuple, and changing each of these values identifies a different socket. Therefore, unlike UDP, segments with same destination port may not end up in the same socket. For example, let's say host A initiates a connection to host B, which is from host A's port 9157 and goes to the port 80 of host B. Host C also initiates a TCP connection to host B from its port 5775 to host B's port 80. These packets will end up going to different sockets at the server B, which is identified not only by port 80, but also with the 3 other values in the 4-tuple. Hosts may have more than one connection among different processes. For example, we can have another different connection between servers B and C. Also, same source ports might be used among different hosts communicating with the same host server. For example, if host C communicates with a port number 9157 on its side, which is exactly same port value host A has used, the segment arriving at server B will have destination port 80 and source port 9157, exactly same as those values in the segment from host A. The IP address of the destination on the datagram is also the same. However, since the source IP address in the datagram is different, these segments will be sent to different sockets and separation of the connections will be maintained. Note that the server application is running at multiple parallel processes in this example. This could alternatively be handled with threading and the same application having different sockets with different identifiers in the same process and within the threads.